So what we're going to look at is the notes that I shared with you on the effects of a coefficient on x squared or the constant at the end of the quadratic. So I'm going to do all of this through Desmos, and I will talk you through how it changed and how it affected the graph itself. So I'm going to start with number 1. This is our original parabola. So what we're doing is comparing the transformation to the original parabola. So obviously I don't have this turned on just yet. So we're looking at the key features and how it's changing my key features. So when I change x squared to negative x squared, you'll notice that now I have the exact same parabola, but it's been reflected and now is all negative output values in this case. My vertex went from being a minimum to a maximum, and my graph is now opening down. So if we talk about what changed and how it affected the graph, the coefficient became negative. So a negative coefficient reflects the graph from wherever it was to being completely upside down and the opposite of before. So that was number 1. So it's a reflection. I'm sorry, the dogs are in the background. It's a reflection. So here you'll notice I have transformations 1 and 2. So again, I'm starting with the same original parabola, the same parent function. So I'm going to compare what happens with 3x squared and with 5x squared. So if I change my coefficient to 3, I went from the red parabola to the blue parabola. So it's gotten skinnier and it's changing faster. My y values are getting larger faster. So if I change this to 5x squared, now I'm changing even faster than 3x. So the coefficient, if the coefficient gets larger, the graph will become skinnier and my y values will get larger faster. Now, if, I'm going to turn these off for just a moment, if this was negative and I was comparing all of these with negative, I would see the exact same thing, except now my y values would be getting larger in the negative direction faster. So I'm going to have more negative numbers much faster. Same thing, if I made this negative 5x squared, it's going to be a skinnier parabola and we're getting more negative faster. So it doesn't only happen if it's a positive coefficient. It happens for negative coefficients as well. So this is if I have larger coefficients. Now I'm going to look at what happens if I make my coefficient a fraction. So if a larger number made my parabola skinnier, fractions do the opposite. Fractions make my parabola wider. So 1/2 made it a little bit wider, but 1/8 makes it much wider. So now this is where you got to kind of put your thinking cap on a little bit. 1/8 is a smaller fraction, but it made my graph the widest. So the smaller the fraction, the wider the graph. Now it does have to be a fraction that is less than 1, because if I changed this to 3 halves, this is now a number that is larger than 1, and it made my graph skinnier. But if it's a fraction that is less than 1, it will make my graph wider. So the smaller the fraction, less than 1, the wider the graph. If the fraction is larger than 1, then we fall into the last examples we were doing, question number 2, and the graph will be skinnier. Now you'll notice both of these are positive coefficients, because we know from example number 1 that a negative coefficient does something different. I'm only considering the fraction itself, not whether it's positive or negative. All right, last but not least, now I'm going to keep x squared the same, and I'm going to mess around with the coefficient and see what happens. Now you'll notice right now the vertex is at 0, 0. This is also my y-intercept, and it also happens to be my x-intercept. But I want to focus on what's happening with the y-intercept. So when I turn on this, it shifts my entire graph up 4 units. So here, this point was 1, 1. If I could get right on 1, 1. I'm not going to be able to, but we can pretend. So this point right here is 1, 1. And now when I shift it up 4 units, I'm going from 1, 1, up 1, 2, 3, 4, to 1, 5. This point right here was 2, 4. If I shift that up 4 units, now I'm at 2, 8. So this plus 4 is shifting my graph up 4 units, and this plus 4, that constant, also will tell me what my my y-intercept is. So here, now if I do minus 5, my entire graph has shifted from the red down 5 units. So now I'm at 0, negative 5 as a y-intercept. This point of 1, 1 got shifted down 5 units. 1, 2, 3, 4, 5. That's why it's now at 1, negative 4. But like I said, this constant here at the end, we're looking at for our y-intercept. I could add a center term in here, which, yes, moves my parabola a little bit. It's changed the axis of symmetry, but the y-intercept has not changed. So this constant on the end will help you determine your y-intercept. So if it's positive, it will shift your graph up, so you will have a positive y-intercept. If it is negative, it will shift your graph down so that you have a negative y-intercept.